Good morning. We are Carlo and Cesar, and this is our reading comprehension for activity 5. We're going to present to you about work sequences to generate a corporate presentation.
Explaining work center scheduling. Implication. Nature and importance of centers. There are different types of work centers, like continuous processes, high volume manufacturing, mid volume manufacturing, and low volume manufacturing. Each of them handle different products, such as chemical steel, wire, and cables for continuous process, automobiles, telephones, fasteners, textiles, motors, household fixtures for high-volume manufacturing, industrial parts, and high-end consumer products for mid-volume manufacturing, custom or prototype equipment, specialized instruments, low-volume industrial products for low-volume manufacturing. Characteristics for continuous processes. Full documentation, low labor content, and product cost, facilities dedicated to one product. Characteristics for high volume manufacturing, automated equipment, partially automated, handling, moving assembly lines, most equipment in line. Characteristics for mid volume manufacturing, GT cells, focuses, manufacturers. Characteristics for low-volume manufacturing. Machining centers organized by manufacturing functions, not in line. Typical scheduling approach for continuous process. Finite forward scheduling of the process, machine limited. Typical scheduling approach for high-volume manufacturing. Finite forward scheduling of line, machine limited. Typical scheduling approach for mid-volume manufacturing. Infinite forward scheduling typical priority control. Typical scheduling approach for low-volume manufacturing. Infinite forward scheduling of jobs. Usually labor limited, but certainly functions may be machined limited. Next. Typical scheduling and control functions. The following functions must be performed in scheduling and control and operation. First, allocating jobs, equipment, and personnel to work centers or other specified location. Essentially, this is a short-run capacity planning. 2. Determining the sequence or order performance. That is, establishing job priorities. 3. Initiating performance of the scheduled work. This is commonly termed the dispatching of jobs. 4. Shop floor control or productivity activity control, involving next the job sequence. The work sequence is organized depending on the next steps. FCFS, first come, first serve. Orders are run in the order they arrive at the department. SOT, shortest operation time. EDD, earliest, do the date first. Run the job with the earliest, do a date first. STR, slack time remaining. STR, open, slack time remaining per operation. CR, critical radio. LCFS, last come per serve. Random order or whim. Okay. Priority rules and techniques, scheduling and jobs on one machine. As we see in the next chart, the job sequences represent a different time due to different dates, and the full time depends on the previous data. What happens on each sequence, for example, in sequence B, it's because of the flow time of number A, and that goes on. For example, in job sequence C, it happens because of what happened on A and B. As we can see in the flow of time, we represent 3 plus 7 plus 9 plus 15 plus 16, which equals to 50. If we divide the number of sequences between the flow of time, we will get a rate of 10 days to finish the activity. That's because there are 5 different job sequences. Next. Scheduling jobs on 2 machines. Well, this is different because there are 2 or more jobs that must be perceived on 2 machines in a common sequences. As in the n divided by 1 case, there is an approach that leads to an optimal solution according to certain criteria. The objective of this approach, termed Johnson rule or Johnson method after its developer, is to minimize the flow time from the beginning of the first job until the finish of the last one. Johnson rules consist of the following steps. First, list the operation time for each job on both machines. 2. Select the shortest operation time. 3. The shortest time is on the first machine. Do the job first. If it is on the second machine, do the job last. In the case of a tie, do the job of the first machine. 4. Repeat steps 2 and 3 for each remaining job until the schedule is complete.
Shop floor control, also known as production activity control. Some of its functions are assigning the priority of each shop order, maintaining work in process quantity information, conveying shop order status information to the office, providing actual output data for capacity control purposes, providing quantity by location by shop order for the WIP inventory, and accounting purposes, measuring efficiency, utilization, and productivity of manpower and machines. Tools of shop floor control. Number 1, the daily dispatch list, which tells the supervisor which jobs are to run, their priority, and how long they take. Number 2, the various status and accession reports, including A, the anticipated delay report made out by the shop planner once or twice a week and reviewed by the chief shop planner to see if there are any serious delays that could affect the master schedule. And number 3, an input-output control report, which is used by the supervisor to monitor the workload capacity relationship for each workstation. Principles of work center scheduling. Much of our discussion of work center scheduling systems can be summarized in these principles. Number 1, there's a direct equivalence between workflow and cash flow. Number 2, the effectiveness of any shop should be measured by the speed of flow to the shop. Number 3, the scheduled jobs are a string with process steps back to back. Number 4, once started, a job should never be interrupted. 5, speed of flow is most efficiently achieved by focusing on bottleneck work centers and jobs. Number 6, reschedule every day. 7, obtain feedback each day on jobs that are not completed at each work center. Number 8, match work center input information to what the worker can do. Number 9, when seeking improvement in output, look for incompatibility between engineering design and process execution. Number 10, certainty of standards, routings, and so forth. This is not possible in a shop, but it always works towards achieving. Personal scheduling in services. The scheduling problem is in most service organizations revolves about setting weekly, daily, and hourly personal schedules. Schedule Source Incorporated of Broomfield, Colorado, They offer an integrated suite of tools for workforce management named Teamwork. The way it works is this. Step 1, define labor requirements. Step 2, establish employee availability. Step 3, assign employees to particular skill sets and rank an employee skill set level from 1 to 10, 1 being novice, 5 being average, and 10 being superlative. And finally, step 4, the Teamwork software actually builds a schedule. And scheduling hourly work times. Here can be applied the first hour principle. Assume that a worker works continuously for an 8-hour shift. The first hour rule says that for the first hour, we assign a few workers equal to the requirement in that period. And for each subsequent period, assign the exact number of additional workers to meet the requirements. When in a period one or more workers come to the end of the shifts, add more workers only if they are needed to meet the requirements. And here we can see in the following table some information about this. Here you can see the hours and the requirements for each hour. The schedule shows the number of requirements for each time, and it also proves that the number of activities are different depending on the hour of work for each employee. And that's pretty much our reading comprehension. We hope you enjoyed it. Thank you.